It's now time to have a look at managing default and special permissions. Now, there are three special permissions that exist. Those are the sticky bit, the set group ID bit, as well as the set user ID bit. Let's have a look at the sticky bit. It's typically set in directories, and how you would go about identifying whether the sticky bit is present on a directory is the T permission is present where there should be an X for the other element. So let's have a look. I'm going to create a directory called data. And let's have a look at the permissions right now. So these are the permissions that are in place for other. There's no T, and that means that there's no sticky bit that has been set. The whole idea around the sticky bit is that when used on a collaborative directory like data or common or some sort of other collaborative directory, it means that while users may go and create files in that directory, because they'll have the right permission, only those owners are able to delete their files. So I'm setting the permissions to read, write, and execute for everyone over there. And here we have a bit of a scenario where the user Fred comes along and Fred creates a file. So Fred's going to change to that directory and Fred's going to create a file called fredfile1. That was successful. Remember, it is successful because Fred has got right permissions to the data directory. Fred logs out, and here comes Wilma. And Wilma comes along to the data directory. And the question is, can Wilma delete the file called fred.file1? Don't have a look at the permissions of the file. Let's go and have a look at the permissions of the directory that hosts that file. Now we have it over here. So what we can see is that Wilma's not the owning user. Wilma's not a member of the owning group. Wilma is therefore qualified by other. Other has read, write, and execute permissions. So if you wanted to delete a file from a directory, you would need the right permission. So let's have a look at the scenario. Wilma comes along, sees fred.file1, and is able to delete it. Now, this is what you don't want in the workplace. You want your users to be able to collaborate, to work together in the same directory, but you don't want one user to delete files that they have not created. And this is where the sticky bit comes in. As the root user, what I'm going to do right now is create or set the sticky bit on the directory. And you can do so in a few ways. I'm going to use chmod o plus t. And we're going to do this for the data directory. And if you have a look at this right now, the output of the ls command, you'll see that when it comes to the permissions for other, it now reflects RWT. Now the T is there to indicate that the sticky bit has been set. If it was an uppercase T, it would mean that the sticky bit was set, but not the execute permission for other. So lowercase t means that the sticky bit is set as well as the execute permission for other. So let's have a look to see how this impacts the data directory. So Fred comes along and Fred changes to the data directory. Fred creates a file called fredfile2. That file is now present. Wilma logs into the system and Wilma attempts to delete that file. Now the big question over here is, does Wilma have permissions to delete that file? And the answer is a resounding yes. In order to delete a file from a directory, you need the right permission. Wilma does have the right permission, but the sticky bit is there. And the sticky bit will result in the error message, operation not permitted, because the sticky bit prevents users from deleting files that they are not the owners of. And that's exactly what we have. The next special permission is the set group ID bit. And the whole idea around using the set group ID bit is again with collaborative directories, because when you create a new file in a directory that has the set group ID bit, the owning group will be inherited from the parent directory. Let's have a look at this in more detail. So how we would go about identifying whether the set group ID bit is set is the S permission in place of the X for the owning group. So the permissions for the owning group right now are read, write, and execute. There's no set group ID bit. Another item that we need to be sure of is who the owning group is of the directory. So what I'm doing is that I'm setting up a collaborative directory for the group Flintstones. So let's go and set the ownership to Flintstones for data. Oh, crikey, I'm logged in as Wilma still. Let's go and try that again. So as root, I've now changed the owning group to Flintstones for data. And what we can see over here is that the set group ID bit is still not set. The ownership has been transferred to the group Flintstones for the data directory. So to set the set group ID bit, we would make use of the command chmod g plus s. And if you have a look at the permissions right now, you'll see that there is an S permission in place of the X for the data directory. So what this means is that any newly created files in the data directory will have the owning group set to Flintstones. And that means that if you are a member of the group Flintstones, you will automatically have some permissions to the newly created file. Let's go and put that into place. I'm logged in as the user root. Root is not a member of the group Flintstones. However, when I create a file below the data directory, and the file that I'm creating is called root file 1, what you will see over here is that the file will have its owning group automatically set to Flintstones. So if you are a member of the group Flintstones, what this means is that you've got some form of access to the file that I created. And that's the whole idea around making use of the set group ID bit. It's collaboration. Finally, we are going to have a look at the set user ID bit. And identifying the set user ID bit happens when you have an S in place of the X for the owning user. So the question that I have for you right now is, can the user Fred run the executable usr bin cat? Well, what do you need in order to run code? You need the execute permission to execute the code, and you need the read permission to see the code. So is Fred the owning user of that file? No. Is Fred a member of the owning group? No. Fred is therefore qualified by other, and other has read and execute permissions. So as the user Fred, I'm going to attempt to run cat, and it is successful. It appears to be hanging, but it's not. Now, can I run the executable cat to display the contents of the file etc shadow? Well, what you can see over here is that no one has any permissions to that particular file. So Fred comes along and tries to execute the cat command against etc shadow, and it says permission denied, and rightfully so. Now, there's no stopping root. Root is the most powerful user on your system. Root can see any file. So what I'm going to do is that I'm going to prove it to you by showing you the contents of etc shadow. That was indeed successful. So what I'm about to do right now is execute the cat command against etc shadow. However, I'm going to give the cat command the set user ID bit. Now, whenever a user executes a command, an executable that has the set user ID bit, what it means is that that executable runs with the permissions of the owning user. So this file is owned by the user root. It doesn't yet have the set user ID bit, but when it does, that file will execute with the permissions of root. Let's go and put that to the test. So I'm going to use the chmod u plus s command against usr bin cat, and what you can see over here is that the set user ID bit has been placed on that file. So should Fred come along, and if Fred executes usr bin cat, it will run with the permissions of that user, in other words, root. Let's go and put that to the test. Cat, etc shadow, and look at that, it now works. Do be aware that it does not work if you set the set user ID bit on a shell script. It will only work for binaries.